Ready. Today we're going to be learning about mass mole conversions. So last lesson we learned about thing mole conversions. We talked a little bit what mole is, what molar mass is, and all that stuff that's used for conversions. Now we're going to complete our mole island map. This time we have mass island, and the unit for mass is grams. If we're going from mole to mass, molar mass is going to be on the top and 1 mole is going to be on the bottom. And if we're going from mass to moles, 1 mole is on the top and molar mass is on the bottom. So with that idea, let's go ahead and practice some molar mass conversions so you know how to get molar mass numbers needed for our conversion factors. So with that idea, let's go ahead and do some practice problems of calculating molar mass. Now, just a heads up, make sure you have your periodic table out and open, ready to go, because you need to refer that to get the element's atomic masses. And remember, they are the last number below the atomic name of all of the elements. So we're going to calculate the molar mass for the following compounds. And our first one is we're going to do K3PO4. The first thing we're going to do is we're going to underline all of our capital letters. We got K, P, and O. That is going to help us determine which element is which. So in this case, we know there's 3 elements in this compound. Looking at our first element is K. Finding K on the periodic table, that is potassium. Potassium has an atomic mass of 39.098. Now, potassium has 3 in this, there's 3 potassiums in this compound. Therefore, we have to multiply this number by 3. And since we're taking the sum of all of them, we have to put that in parentheses because that represents K. And we're going to add because sum is addition. And then we're going to move on to our next underlined element. And that is P. Finding P on the periodic table, which is phosphorus. It has an atomic mass of 30.974. Now figure out how many P's we have, how many phosphorus we have in the compound. There is no number after phosphorus. That means it's 1, because in chemistry, we never write ones. Therefore, there is one phosphorus in the compound, so we're going to multiply this number by 1. And then moving on to our next capital letter, which is O, finding O on the periodic table, that is oxygen. Oxygen has an atomic mass of 15.999. And in the compound, we actually have 4 oxygens, so we're going to multiply this number by 4. Now, plugging this into your calculator, make sure if there's a parentheses, you put the parentheses in your calculator, because if you don't, calculators do not do order of operations. So make sure you're plugging it into your calculator exactly how you see it. And you're going to get 212.264 grams/moles. And that is your answer for problem number 1. So with that same idea, let's go ahead and move on to problem number 2. That is MgOH2. Again, we're going to underline all of our capital letters first. And this lowercase g actually goes with capital M. So we have Mg as one element, O, and then H. So looking at our first underline, which is Mg, on the periodic table, which is magnesium, it has an atomic mass of 24.305. Now, looking at how many we have in the compound, there is no number after Mg, so it's going to be a 1. So we have 1 Mg, so we're going to multiply this number by 1. Moving on to our next underline, which is O. O on the periodic table is oxygen, and that has an atomic mass of 15.999. Now, you may say we have 1 oxygen, because we have 1 after oxygen. But you see how we have this 2 after our parentheses? That has to be distributed to all of the elements in the parentheses. So we also have 1 hydrogen in the parentheses. So 2 times 1 is 2, and 2 times 1 is 2. So we actually have a total of 2 oxygens and 2 hydrogens. So we're going to multiply 15.999 by 2. Moving on to our last underline, which is H, which is hydrogen. Hydrogen has an atomic mass of 1.008, and since we have 2 of them in the compound, we're going to multiply that number by 2. Again, plugging this in all into your calculator, you get 58.318 G/mole. Now problem number 3. Again, let's go ahead and underline all of our capital letters. And if you see we have a lowercase here, that's going to go with the capital letter before it. So we have F-E, S, and O. So looking at our first underline, which is Fe. Fe has an atomic mass of 55.845. We have 2 of them in the compound, so we're going to multiply the number by 2. Next, we have sulfur, S. It has an atomic mass of 32.066. Now, we do have one of them in the parentheses, but remember, when we have a number outside of a parentheses, we got to distribute that. It applies to both numbers. 3 times 1 is 3, so we have 3 sulfurs. 3 times 4 is 12. We have 12 oxygens. So since we're looking at sulfur, we're going to multiply this number by 3. Last underline is oxygen. Atomic mass is 15.999, and we have 12 of them. Plugging this into the calculator, you get 399.876 grams/moles. So with that idea, go ahead and do problem number 4 and number 5 on your own. Go ahead and pause the video, and when you have your answer, press play. And here's your answer. So when we complete mass mole conversions, we need to make sure we do the following. We need to make sure our answer should be in the same number of significant figures with what we started with, and our answers must have a unit and compound/element following the number. These are the exact same things from when we did thing mole conversions. All right, let's go to do some examples of mass mole conversions. Problem number 1 says how many moles are in 5.00 grams of CaCl2. Same kind of steps we did when we did thing mole conversions is we're going to circle what we are given and underline what we're trying to solve for. So in this problem, we are given 5.00 grams of CaCl2. The problem is asking us to solve for moles. Since I circled grams, that is going to be mass island now. And I'm trying to solve for moles. So now that we know what we're starting with and what we're going to, let's go ahead and rewrite what I circled. 5.00 grams of CaCl2. And again, we still got to do our conversion factor. If you look at the mole island map going from mass to mole island, you're going to see that 1 mole is on top and molar mass is on the bottom. So we have to solve for the molar mass of the compound we have. The compound that we currently have is CaCl2. So we have to solve the molar mass of that compound. So let's go ahead and do that. Got to find the molar mass of CaCl of CaCl2. So the atomic mass of our first element, which is calcium, is going to be 40.078. And we will go ahead and multiply that by 1 because we only have 1 of them in the compound. And chlorine's atomic mass is 35.453, and we only have 2 of them in the compound. So when we plug this into our calculator gives us 110.984 grams/mole. And that number goes on the bottom, where our mole island map tells us our molar mass is going to be at. And because we already have our slash and our mole and slash and the mole in the unit, the only unit left over is grams. We have 2 grams, so we're going to cancel that both. And now we are good to solve it. Just like before, we're going to multiply the top and divide the bottom. And when we do that, our calculator gives us 0.04505, but we have to round that to the proper number of sig figs. The number of sig figs we start with should be the number we end in. We actually start with 3 sig figs. So our first three significant numbers is 5450. The 5 tells me the 0 goes up. So our final answer is going to be 0.0451 moles of CaCl2. And that is our final answer for problem number 1. So let's go ahead and move on to problem number 2. Problem number 2 says it says how many grams are in 2.25 moles of FeCl3? Well, we're given 2.25 moles of FeCl3. The problems ask us to solve for grams. Therefore, since I circled moles as my given unit, we are going to start at moles this time. I underlined grams, so we're going to end at mass this time. So now that I know what I'm starting with and what I'm going to, we can rewrite what we circled, which is our 2.25 moles of FeCl3. Again, that multiply in the line. And if we look at our mole island map, if we're going from mole to mass, molar mass is on top and 1 mole is at the bottom now. So now we have to solve the molar mass again, but for the compound that we have in our problem, which is our FeCl3. So let's go ahead and solve the molar mass of that, of FeCl3. The molar mass of iron is 55.845. And we have 1 of them in the compound. And the atomic mass of chlorine is 35.453, and we have 3 of them in the compound. When we plug this into our calculator gives us 162.204 grams/mole, and that number goes on the top. 0.204 grams. So looking at our problem at work, we have 2 moles, so both of those moles are going to cancel. And now we're good to solve it. So just like we've done before, we are going to multiply the top and divide the bottom. And when we do that, our calculator is going to give us 364.959, but again, we have to round. The number of sig figs we start with should be the number we end in. We start with 3 sig figs. So we're going to end in 3 sig figs. The 9 tells me the 4 goes up. So our final answer is 365. We're solving for grams of FeCl3. And that is your final answer for problem number 2. Alright, so let's go to move on to problem number 3. It says how many moles are in 20 grams of CO2? We are given 20 grams of CO2. We need to solve for moles. Grams is mass, so we're going to start at mass island. And moles is moles, so we're going to end at mole island. So now that I know where I'm going to start at and what I'm going to, let's rewrite what we circled, which is 20 grams of CO2. Always follow the times in a line. If we're going from mass to mole, our mole island map tells us 1 mole is on the top and molar mass is on the bottom. So we have to solve for the molar mass of the compound we have, and we have CO2. So let's go ahead and solve for the molar mass of CO2. So carbon has an atomic mass of 12.011, and we have 1 of them in the compound. And oxygen has an atomic mass of 15.999, and we have 2 of them in the compound. And when we plug this into the calculator, we get 44.009 grams/moles. And that number goes in the bottom, grams. Now in this problem, we have grams repeating, so we're going to cancel, and we are good to solve. So we are going to go ahead and multiply the top and divide the bottom. And when we do that, our calculator is going to give us 0.4544. But again, we have to round. Number sig figs we start with should be the number we end in. We start with 1 sig fig. So our first significant number is 4. The 5 tells me the 4 goes up. So our final answer is 0.5 moles of CO, of CO2. And that is our final answer for problem number 3. So now let's go ahead and move on to problem number 2. It says how many grams are in 1.87 moles of AlCl3. We are given 1.87 moles of AlCl3, and we need to solve for grams. Moles is mole island, grams is mass island. So we know we're going from mole to mass. So now that we know where we're starting at and what we're going to, let's go ahead and rewrite what we circled. 1.87 moles of AlCl3. That conversion factor. If we look at our mole island map going from mole to mass, molar mass is on the top, 1 mole is on the bottom. So we have to find the molar mass of the compound we have in our work, which is our AlCl3. Aluminum has an atomic mass of 26.982, and we have 1 of them in the compound. And chlorine has an atomic mass of 35.453, and we have 3 of them in the compound. Plugging that all into our calculator, we get 133.341 grams/moles, and that goes on the top. We have 2 moles, so they're going to cancel, and we are good to go ahead and solve that. We are going to go ahead and multiply the top and divide the bottom. And when we do so, our calculator gives us a value of 1.87 times 133.341. We get 249.34767. Again, we got to round, so we start with 3 sig figs. So we have to end in 3 sig figs. The 3 tells me the 9 stays the same, so we have 249. We solve for grams of AlCl3. And that is your final answer. So go ahead and do problems number 5 and 6 on your own. Pause the video, and when you have your answer, press play. And here's your answer. And that's it, guys. Thanks.